Hey, this is Abstraction Game. I'm going to show you today how to reverse a singly linked list, but I'm going to pretend that I don't know the answer in advance, and I will show you how to actually infer the solution from simple test cases, so that you will not only learn the solution to that given problem, but you will also hopefully learn how to approach the problems when you don't know the answer in advance, and how to figure the answer by yourself, which will eventually be useful either in your career or in technical interviews, because eventually everybody faces some problems that they have not seen before. I'm using HackerRank. This is useful because HackerRank gives me this code in which I only need to fill the reverse function in Python, and actually creating the single linked list and communicating with the user and testing this code, and all of these things are done for me. So I only need to take care for this function which accepts pointer or reference. In case of Python, the difference is subtle between pointer and reference, to the first element of this list, and it's supposed to also return the first element of the reversed linked list. And what we're gonna do is we're gonna specify a custom test case, which consists of one list which has 5 elements, and these are the values of the data field in the subsequent nodes of this linked list. And we're going to try to actually manually reverse this list, which contains values 1, 2, 3, 4, 5, and then pointer to none or null, to 5, 4, 3, 2, 1 none, because this hopefully will let us infer how to solve the general case. But now we're just gonna solve this very simple case manually, so that the patterns that allow us to generalize the solution will become clear and intuitive. So this is the input list that we have specified in the test case, and the last points to none. And this is important because if it was still pointing to something, we could easily have some unpredictable behavior, like cycle in a list, for example. And this is the target. And how are we gonna get there? Okay, let's see. The first element has to point to none. The second element has to point to element 1. The third element has to point to element 2, 4 to 3, 5 to 4. Okay, so the reference to the next element of the first one is supposed to point to none. Then okay, and here's the problem. We don't have access to second element now, because normally the second element before starting reversing would be head next, but head next is now none. So how do we get here? We have no way. So we actually have to store the reference to this element somewhere in some temporary variable. So let's call it store2, so that we know what it actually does. Cool. Now we can actually use this and make it point to head, so the element which holds the value 1 And again, we have no access to element 3, so we need to somehow store it. So we could, for example, go here and do something like this. This is the turf element, or we could just use the variable which stores element 2 and then use that pointer to next element. And this is crucial. We need to do line 53 before line 54, so before we ruin this pointer. Okay, and now let's use the start node, the start reference to node. And again, we have no access to 4, so we store 4. And of course, we have to do it before we ruin store 3 next pointer. So the order is crucial. If we would mix the order of lines, the whole thing won't work. And we have no access to 5, so store 5. And let's point 5 to 4. And it seems that store 5 is our new head. Let's run this code. Let's see what comes out. Okay, this is exactly what we're trying to achieve. We have now the reverse link with 4, 3, 2, 1 order. And the next step will be trying to actually generalize this idea so it works for arbitrary number of elements. Whenever we encounter a list, we can expect to have to traverse it, so either iterate through the whole list using loop or recursion. I prefer loop, which is also more efficient. Sometimes you will have to walk through the whole list multiple times. Sometimes you don't need the whole to walk through the whole list, because there will be some condition which will stop the loop prematurely. But in general, whenever we need a general solution, we need some sort of loop that will enable us to do something with each element of the list. So let's write the easiest possible loop. So while loop, let's imagine that we have some current node, some part of the list, that single element of the list which is subject of our focus right now, is not known. So while we actually have this element available and it's not empty, and we only need one operation, so this is the operation which prepares the next step of the loop. And let's say maybe we'll also add printing the data in current element, and we will also initialize the current node variable. So in the first pass of the loop, this is true. So that's the simplest possible loop. Okay, on debug output we can see that it actually works. So this is our base for every list related solution that doesn't involve recursion. This is actually, we can actually omit it because car evaluates to true whenever it's has value different than none. It cannot have value 0 because it's an actual reference, so we can make it a little bit simpler. Okay, let's maybe also comment out our older code so it doesn't get into way. And so we were doing two operations. We were assigning the current element that was our focus to the previous element. So so this would be something like this, assigning current element to the previous element. We don't have access to previous element, but for now I'm just writing all the instructions I need, and then I will worry later how to actually provide values for these instructions. Okay, so we need to actually store the next element, because each time we were iterating through this list, we needed the next element because we were losing the reference to it. So I will have so let's call it store next. And I guess now we can try to figure how do we get previous element. And well, if we would we can mentally divide this loop into two sections. Current iteration maybe, and preparing next iteration. And previous for the next iteration will be actually our current element, and the future current element will be the next element from our current. And we can clearly see that we don't have access to this anymore, so I will actually use store next here. And the only thing we're missing is that in the very first iteration of the loop, this will be initial. It won't be initialized because yeah, let's actually run it and see it fail. Yeah, exactly. That's the error. Let's actually think, when does it occur? It actually only occurs in the very first iteration, and as we remember from doing this manually, in the very first iteration we were pointing the first element to none. So let's actually just initialize it with none as well, because this is exactly the operation we need. Okay, and we're also missing the return instruction, which should return our last element, or actually our last element will be already pointing to none when this doesn't execute. So the last actual real element that holds value will be our pref. Okay, seems okay so far. So let's now to comply with the HackerRank thing, get rid of the print, and let's submit the codes. Okay, it seems that it passed all their tests. So it seems the solution is okay. So what is left for us to do is maybe some cosmetics, so we can get rid of our code that we're not using anymore, since we're never ever using the head value. we can actually get rid of this line and just call it current here. And this was useful for us to explain what we're doing, but usually most of the developers know how to write loops, so we can get rid of this as well. So that's it. That's our 6 lines long solution. Let's compare it to the other solutions that people proposed for this challenge. Okay, this guy seems to be doing what we have done, more or less, but this looks too complicated. This is probably C++, which doesn't matter, it's C++. So tail, what is tail for them? Okay, that's our previous. And where do they have current elements? Okay, they just called current element head all the time. This, I guess it makes sense because this is the head of the part of the list we haven't reversed yet. This looks pretty complicated. Okay, there are these safeguards. We might also want to add safeguards so it doesn't execute when current is known. Okay, actually it won't execute if current is known. So we don't really need this. What if we get a single element list? Because this is what they take care for in here. Let's see what happens then. If the whole list has just one element, so one list with one element, and this is the value for this element. No, nothing breaks. So it seems that we're safe for that as well. Oh, this is super easy. It's, I mean, it's even shorter than our solution, but oh, I don't actually like it because instead of reusing the existing data structures nodes, they will create new node each time instead of actually reversing the pointer, pointing it from 3 to 1 or 4 to 2 or from n+1 to n-1, they will actually create new element. It saves them one line of the code, but it creates this data structure node 5 more times. So imagine you have 1 million elements. With this approach, you would get 2 million elements, although probably at some point the unused one will be garbage collected, but still there's no need. This looks complicated, but okay, yeah, but this actually you don't need it because you have it here in first iteration. Okay, this is the same solution that we used. And one more interesting thing is that long time ago, my intuition, you can see how long I was trying to compile it for this video. I would create an array that was keeping the elements, and I would iterate it back. And this is obviously you can do it that way, but it's overly complicated, and also you have the same data stored twice, which would mean storing million elements twice instead of once. And one last remark. When I was preparing this it was kind of embarrassing because I had problems with creating the working solution right away, despite having solved this problem on multiple occasions. And this is because I was trying to work with element, because in our solution that worked, we were working with element number n, so the one which is currently the focus of our loop. We were referencing element n-1, so the previous one from previous iteration, and we were also doing something with the next element, right? So we had okay, yeah, how do I open editor? So we were looking at these elements when n is current element. If you try to approach this problem in a different way, that okay, n is your current element, and you're trying to, so let's say it's yeah, the data is 1, and you're trying to point the n plus 2, so 3 elements, to element number 2, so to n plus 1, then it's gonna get messy really quickly. Then handling the pointers is not gonna be so straightforward, and yeah, whenever you get yourself lost in a very simple problem like that, think that maybe you should consider different set of elements. Maybe instead of n plus 1 and n plus 2, you could consider n minus 1 and n plus 1, or just move your focus frame by 1 in any direction. Can often help you to find a really simple solution. That's it. Good luck in your future algorithms endeavors.